In this video, I wanted to talk about frames. So frames are pretty similar to trusses, except they're not limited to two force members. So you can have a member in a frame that is not loaded at the joint. It could be loaded in the middle of a member, or at the end of a member if there's not a joint there. So the steps to solving these are a little bit different from frames, or from trusses, I'm sorry. But overall, they're pretty similar. Your first step is going to be to solve for global equilibrium where you can. You won't always be able to find every single reaction in a frame from the get-go. And then the second step is to draw a free body diagram of each non-two force member. So the reason you don't need to draw a free body diagram for a two force member is because it doesn't really tell you anything, right? This is what it would look like, and all that tells you is that F equals F. So you don't really learn anything new from that. And your third step is to solve for equilibrium in each member that you drew a free body diagram for. So I have an example problem here that I want to run through. We can tell this is a frame because we're loaded here at C, and that's not a joint. So we know off the bat this is going to be a frame problem. The question is, find the forces at the joints A, B, and D. So our first step from above is solve for global equilibrium. So I know I'm going to have reaction forces here at A and D. So if we think about this, if I take a moment about A, this force at C is going to rotate me clockwise. So at D, I know my reaction force in the x direction is going to go that way. And then I can also put in my reaction force at A because it has to counteract that in the x direction. Now in the y direction, I don't actually have enough information to pick which direction it'll go. So I'm not going to draw those yet. So let's go ahead and solve for this rdx. So we have the sum of the moments about A equals 0. And so in the clockwise direction, we have 2 kips. That's negative 2 times how far away? It's 2.5 feet. And then in the positive direction, we're going to have rdx, and that's 1.5 feet away. So rdx is going to be 3.33 repeating. That's in kips. All right, so there's one of our answers. We can also go ahead and solve for rax. It's just going to equal rdx, but it's going to be pointing in the opposite direction, but the magnitudes are going to be the same. So sum of the force in the x is 0 equals our rax minus our rdx, which is 3.33. So rax equals 3.33 kips. Okay, so we have the x components at joints A and D, but we still don't have enough information to solve for the y components. So let's go ahead and move on to step 2, which is to draw a free body diagram of any non-two force members. So this one we only have one, which is going to be this member along the bottom, A, B, C. So what forces do we have on here? We have C, loaded C, which is 2 kips. We have A, and we know the x component of that is 3.33. And at B, since C is pulling down, I'm going to assume just intuitively that this member here, BD, is under tension. So that's going to be pulling on this joint off in this direction. I'm going to go ahead and break that down into components. And then from here, we can actually just intuitively figure out the direction of A as well. So if I take a moment about B, this force at C is going to rotate me clockwise. So at A, we have to rotate it counterclockwise. So we're going to be going down like that. That's So reaction force y. Okay. So now we can go ahead and solve for a few of these. So right off the bat, we can get FBX. That's just going to be equal to 3.33 kips. And you would do that by taking the sum of the forces in the x direction on this member here. And then we can solve for FBY by doing the sum of the moments about A and setting that equal to 0. And this is not global A, this is A of this member right here. So in the positive direction, we have FBY, and that is 1 foot over. Then in the clockwise direction, or negative direction, we have this 2, and that is 2.5 feet away. That's this load here. FBY is going to come out to be 5 kips. Okay. So I have both of my forces at B, and the only one left is this reaction here at A in the y direction. So we can just do the sum of the forces in the y direction equals 0, and again, that's of this member right here. So that's going to equal our RAY, which is negative. Then our FBY, which we just found, is plus 5, and then minus 2. So my reaction at A in the y direction is going to be 3 kips. Okay, so the only unknown that we still have left is this reaction up here in the y direction. So let me draw this one here. It's my RAY. Now if these are both going down, I know that this one has to go up. So my RDY has to be going up. And to solve for that, we can just do the global sum of the forces in the y direction equals 0. So that's going to equal my RAY, which was negative 3, and then minus my forces C, and plus my RDY. So RDY equals 5 kips. And just kind of a quick spot check on these. My forces at B should be equal to my forces at D, which they are. So my x component at B equals the x component at D, and the y component at D equals the y component at B. But yeah, these problems aren't too bad. They're just a little bit harder than trusses, but I hope this helps.